74. Let's go ahead and jump right into this. Here we go. Okay, let's graph this quadratic inequality. The first thing we're going to do is find the x value of the vertex, negative b, or negative b over 2a. Okay, so here we go. A equals negative 2. B equals 4. Okay, so where the b is up top, I will put a 4. In the denominator, where a is, I will put a negative 2. Okay, so I have 4 over 2 times negative 2 is a negative 4. I also have a negative out front. So the whole fraction becomes negative. A positive over a negative is a negative. So the whole fraction becomes negative, but then there's a negative out here, so the whole fraction becomes positive. It's like having a negative, negative, and then a fraction. Okay? So the whole fraction becomes positive. And 4 over 4 is 1. So I just found the x value of the vertex, 1. Now let's find the y value, okay? So, let's put 1 in for x. So negative 2 times 1 squared, positive 4 times 1, positive 8. 1 times 1 is 1 times negative 2 is negative 2. 4 times 1 is 4. Bring down your positive 8. 12 minus 2 is 10. So my other x value, or the y value of my vertex is 10. So let's go ahead and put our table of values right here. We'll squeeze it in here. And right in the middle we'll put 1, 10. Now if we have a 1 here, we'll go up to 2, 3, and down to 0, negative 1. Okay? Let's substitute 3 in for x. Negative 2. 3 squared. Positive 4 times 3, positive 8. 3 times 3 is 9, times negative 2 is negative 18. Then we have a positive 12 and a positive 8. If you combine those, you will get 2. Alright? 2. So when you put 3 in, you get out a 2. Now, when I put negative 1 in, I should also get out 2. Let's see what happens, okay? Here we go. Negative 2, and then 1 for x. Positive 4, and then 1 for x. Positive 8. 1 times 1 is 1 times negative 2 is negative 2. Positive 4, positive 8. And that's going to give you, that's not correct, is it? Let's see if I made a mistake somewhere. Okay, students, I'm back. I see what my mistake is. It should be a negative 1. Put a negative here and a negative here. So, negative 1 times a negative 1 is positive 1 times negative 2 is negative 2. 4 times negative 1 is negative 4. And then negative 8. When you combine these, you will get a 2. Alright, next we're going to substitute 2 in for x. So negative 2 parentheses 2. Positive 4 parentheses 2, positive 8. When you square the 2, you get a 4. 4 times negative 2 is negative 8. 4 times 2 is a positive 8. And then a positive 8. Well, these will cancel out, leaving you with 8. If you combine all those, you get 8. If you put 0 in, you will also get out 8. So we're pretty good. There we go. Now, as we go to graph our parabola, check to see if it's dotted or solid. It'll be solid because this equal sign here. Okay. So I have 3, 2 over 3 up 2, and then 2, 8. So over 2 and up 8, and then 1 and way up to 10. So 9, 10, and then 0, 8, and then negative 1, 2. So there it is, guys. A perfect parabola, just like we thought it would be. Okay. Now, the last thing we have to do, remember it's going to be a solid parabola. The last thing we do is we have to test an ordered pair to see if it'll fall, to see if we shade inside or outside the parabola. Now, 0, 0 is always our favorite point to check, okay? So in this case, we can definitely check 0, 0, okay? So here we go. Where the y is, I'm going to substitute 0. And where the x is, I'm going to substitute 0. Well, guys, come on, look at this. 0 squared is 0 times 2 is 0. 4 times 0 is 0. Positive 8. 0 plus 0 plus 8 is 8. So I get out an expression that says 0 is greater than 8. 0 is greater than 8. Well, that's false. That's not true. So if this point inside the parabola is false, then I'm going to want to shade outside the parabola. Okay? So here we go. Just go around the parabola like this, shade like that, and that's definitely good enough. Okay, guys. Alright, there we go. Number 26. Okay, first of all, we're going to find the x value of the vertex. We're going to use the formula negative b over 2a. Alright, so negative b is 30. A is negative 3. So 2 times negative 3. Alright, so I have a negative out front. I have a positive 30 up top and a negative 6 on the bottom. A positive over a negative makes the whole fraction negative. 30 over 6 is 5. There's also a negative sign here. So I have negative 5, which makes it, of course, a positive 5. So the x value of my vertex is 5. Okay, now let's substitute that in and let's find the y value. So negative 3, 5 squared plus 30 times 5 minus 50. Okay, now we can do a lot of this in our head. 5 times 5 is 25. 25 times negative 3 is negative 75. 30 plus 30 times 5 is a positive 150. Bring down your negative 50. Okay? Now if we combine all this, we should get 25. Alright? So there we go. There's our vertex. 5, 25. Okay? So 5 comma 25. So I'm going to come over here. Put my table of values over here. And right in the middle we'll put 525, okay? So going up would be 6, 7, going down would be 4, 3, and here we go. Let's see what happens. Let's substitute 7 in first. So negative 3, 7 squared plus 30 times 7, negative 50. Well, 7 times 7 is 49. And then 49 times negative 3 gives you negative 147. 30 times 7 is positive 210. And then negative 50. Okay? So we end up with, let's see, positive 13. Positive 13. Okay? Now let's jump down and put 3 in, and we should get out positive 13. Let's see if we do, okay? Here we go. Negative 3, then parentheses 3 squared, and then positive 30 times 3, and then negative 50. 3 times 3 is 9, times negative 3 is negative 27. 30 times 3 is a positive 90, and then minus 50. If you combine your negatives, you'll get negative 77 and a positive 90, and that's definitely a positive 13. So very good. Now, next, let's substitute 6 in for x. So negative 3, parentheses 6 squared, positive 30 times 6, negative 50. 6 times 6 is 36. And then 36 times negative 3 would be negative 108. 30 times 6 is a positive 180. Then bring down your negative 50. Alright? Combine your two negatives. That's negative 158, positive 180. So we will get out a 22. Now we should get out a 22 here also when we substitute 4 in, okay? So here we go. Negative 3. 4 squared plus 30 times 4, negative 50. 4 times 4 is 16. 16 times negative 3 is negative 48. Positive 120, negative 50. Combine your negative numbers, you get negative 98, positive 120. Combine those and you do get 22. So that checks, okay? So guys, we can use this table of values right here. Not the table of values, sorry. We can use this coordinate plane even though it looks like it's a little too small. We'll just have our y value, our y-axis, be in increments of 3, okay? So my first ordered pair is 7, 13. So over 7, 3, 4, and then up 13. So 3, 6, 9, 12, 13. So the y-axis is in increments of 3. The x-axis is in increments of 1. And yes, you can do that. Okay, the next order pair is 622, so over 6. And then up 22. So 3, 6, 9, 12, 15, 18, 21, 22. So about right there. Next order pair is 5, 25, so over 5. Then up 25, so that's 21, 24, and then a little bit more, 25. Next order pair 4, 22, so over 4, and then up 22. And last order pair over 3, and then up 13, about right here. Okay, so now notice there's no equal sign here like this, so it will be a dotted. It will be a dotted parabola. Okay, that's probably one of the biggest mistakes that students make when they're doing these. Now it looks, I'm about 99% sure that 0, 0 is going to be outside the parabola, but I'm just not going to take a chance. Okay, I'm going to test this point up here just to make sure. Okay, now don't forget that ordered pair is 0. I'm going to go, yeah, we'll go here. It's going to be 0, 3, 6, 9, 12, 15. So 0, comma 15. Now that's the order pair I'm going to check. If you want to check 0, 0, you can. I mean, it's about 99.9% sure that 0, 0 will be outside the parabola. I mean, I don't see it any other way unless this parabola makes a really weird curve, which it can't do. But still, I'm going to pick a point that I know for sure is either outside or inside. And I know for sure this point is outside. Okay, so I'm going to go ahead and actually, I might change it to something a little easier, to be honest with you. I think I'm going to use a point that has smaller numbers, like this right here. I know for sure this is on the inside, and that's 5, comma 0. That's smaller numbers, so I'm going to use this ordered pair here. 5, comma 0. Okay, so where the y is, I put a 0, and where the x is, I put a y. And here we go. And actually, I know what I'm going to get already, guys. Did I not put 5 in already earlier? What did I get out? 25. So I know when I simplify this whole side over here, I will get 25. Because I've done that before. Over here will be 0. Is 0 less than 25? Yes, it is. So is this point. Does it get me out a true statement? Yes, it does. So I'm going to shade where that point is. And that point is inside the parabola. There we go, students. Okay. Alright, moving on to number 27. Okay, students, let's graph this quadratic inequality. Let's first find the x value of the vertex. Negative b over 2a. B is going to be a 6. A is going to be a negative 1. B over 2a. So negative, then a positive 6, then a negative 2. A positive over negative is negative, plus I have a negative sign out front. 6 over 2 is 3. Negative, negative is positive. So the x value of my vertex is 3. Negative parentheses, then 3. Then positive 6, and then 3, and then negative 2. Now students, you do not square the negative sign. You square the 3 first. 3 times 3 is 9. Then bring down the negative sign. 6 times 3, positive 18. Negative 2. I'm going to get out a 7. Okay? A 7 when I combine these 3 numbers. So there's my vertex. 3, comma 7. Okay? So that's going to go right in the middle. Now going up, I'll have a 4 and a 5. Going down, a 2 and a 1. And here we go. Let's substitute 5 in. So negative parentheses, 5 squared, positive 6, 5, negative 2. 5 times 5 is 25, then bring down the negative sign. 6 times 5 is 30. You'll get out a positive 3 when you combine those three numbers. Now let's check out negative 1, and we should get a 3 right here. Excuse me, not negative 1. Let's check out positive 1, and we should get out a 3. So negative parentheses 1 squared, positive 6 parentheses 1, negative 2. 1 times 1 is 1. Bring down the negative sign, negative 1. Positive 6, negative 2. Combine those numbers, and you will get 3. Okay, so next, let's substitute 4 in for x. 4. So negative, then parentheses, then 4. Positive 6, then 4, then negative 2. 16, bring down your negative sign, negative 16. Positive 24, negative 2. That's negative 18. You should get a positive 6. A positive 6. Now let's substitute 2 in and see if we get out a positive 6. Negative, then parentheses for x, then we'll substitute 2 in. Then positive 6, substitute 2 in, then negative 2. 2 times 2 is 4, bring down the negative sign. 6 times 2 is a positive 12, then bring down your negative 2. You do get out a 6 when you combine these, you will get a 6, so that checks, okay? So we're looking pretty good. Notice your parabola will be dotted. Will be dotted, okay? And over 5, 1, 2, 3, 4, 5, up 3. Over 4, up 6. Over 3, up 7. Over 2, up 6. Over 1, up 3. So I plotted each one of these ordered pairs. Each one, okay? And here's what I got. These 5 points here. Now, I'm going to draw my dotted parabola. And again, guys, this is really close to 0, 0. I just don't feel comfortable using 0, 0. 0, 0 might lie on the outside. It might lie on the inside. So I'm going to pick a point I know for sure lies on the outside. 0, 5. 0, 5. Okay, there it is. So, for my y value, I'm going to put a 5. And for my x value, I'm going to put a 0. Well, 0 squared is 0, minus 0 is 0. 6 times 0 is 0. And then negative 2. Do you see what I did? Everywhere there's an x, I substituted 0. Everywhere there's a y, I substituted 5. 0 squared is 0. 6 times 0 is 0. 0 plus 0 minus 2 is negative 2. So 5 is less than negative 2. That's false. 5 is greater than negative 2, so this ordered pair is false. So I'm going to shade inside the parabola, not on the outside, because the point on the outside failed. Now remember, the point you pick to test, it can lie on the inside or the outside. It doesn't matter. Just make sure you know where it lies. Okay? Alright, moving on to 28. Okay, students, here we go. Let's find the x value of the vertex using this formula here. So b is 16, so negative then 16 up top. A is 4, so we have 2 times 4. So we have a negative out front, a positive 16 up top, and a positive 8 in the bottom. 16 over 8 is 2. Bring down your negative sign, negative 2. So the x value of my vertex is negative 2. Alright, now let's substitute negative 2 in and get out our y value right here. So 4 parentheses negative 2 squared, positive 16, negative 2. 4 times 4 is 16. Excuse me. 2 times 2 is 4. Negative 2 times negative 2 is 4. 4 times 4 is positive 16. That's negative 32. So we get out negative negative 16. Okay. So there's the x value of my vertex. Or excuse me, sorry guys. There's the y value of my vertex. Negative 16. So negative 2, negative 16. Going up, negative 1, 0. Going down, negative 3, negative 4. Well, guys, you should be able to do 0 in your head. When you put 0 in, 0 in, you get out 0. I mean, look, 0 squared is 0 times 4 is 0. 16 times 0 is 0. 0 plus 0 is 0. That's pretty simple. Now let's put negative 4 in, and we should get out 0. So 4 parentheses negative 4 squared plus 16 times 4. Negative 4 times negative 4 is 16. 16 times 4 is 64. 16 times 4 is 64. Let's see. Well, this should be a negative 4 right here. There we go. Okay. 16 times negative 4 is negative 64, which gives me a 0, so that checks. Okay, now let's put a negative 1 in for x and see what we get out. So here we go. 4 parentheses negative 1 squared. 16 parentheses negative 1. Negative 1 times negative 1 is 1. Times 4 is 4. 16 times 1 is negative 16. Negative 12. Now we should get a negative 12 here. Let's substitute 3 in and see what happens. 4 parentheses negative 3. Positive 16 negative 3. 3 times 3 is 9 times 4. Negative 3 times negative 3 is 9 times 4 is 36. And 16 times 3 is negative 48. Combine those and you will get a negative 12. So it checks. Okay? So there we go. Now, let's go ahead and pull this up here. And notice my parabola will be a solid parabola. Okay? And my y values have to go pretty high. I'm going to make the y be in increments of 2 and the x in increments of 1. So my first ordered pair is 0, 0. My next ordered pair is negative 1, 12, 2, 4, 6, 8, 10, 12. Then negative 2. My next ordered pair is negative 2, negative 16. So negative 2, that'd be 14. Oh, it's negative. Okay, sorry students. Let's fix that point real quick. Okay, students, sorry about that. I made that mistake here. Let's go back to this ordered pair. Negative 1, negative 12. 2, 4, 6, 8, 10, 12. Then negative 2, negative 16, so negative 2, negative 14, negative 16. Negative 3, negative 12, so negative 3, negative 12, and then negative 4, 0. So it will be a solid parabola. There's an equal sign here. So we're going to come down, hit here, and come up. It goes right through 0, 0, 0, as you can see. And there's my parabola. Now, pick a point that's obviously on the inside or the outside. I'm going to pick this point here. That's obviously, actually I'm going to pick a point on the y-axis. Those are quite often the easiest. So I'm going to check this point here. It's 0, 2, 4, 6, 8, 10, 12. 0, negative 12. I'm going to check that ordered pair. Okay, so here we go. Where the y is, I'll put a negative 12. Less than or equal to. And you know you're going to get a 0 here because you're putting 0 in for x. 0 squared is 0 times 4 is 0. 16 times 0 is 0. You get a 0 here, 0 here, 0 plus 0 is 0. Negative 12 is less than 0. That's true. On a number line, negative 12 is further to the left than 0. So that's true. So this ordered pair is true. So if that ordered pair is true, then we're going to shade on the outside where that ordered pair is. Okay? And there we go. Alright. One more problem. This was a little more difficult, but one more problem. And then we'll be finished. Now, I'm going to get an extra page for this one. I'm going to pull that here. I'm going to make this be our big coordinate plane. We're going to need a pretty big coordinate plane, probably, I'm assuming. Okay, here we go. Let's go ahead and start. What we're going to do, guys, is we're going to graph a quadratic inequality system. So what we're going to have to do is graph this one. And let's say we get a parabola like this, okay? Instead of shading, we draw, let's say you're supposed to shade on the inside. Then we draw arrows. Then we graph the other one. And let's say it goes like this. I'm just making this up. Like that. And let's say it says to shade on the outside. Like this. We've got to shade where the two agree. So you've got a shade inside this one, but outside this one. So it would be something like this. Outside this parabola here, but inside this parabola here. So what we're going to do is we're going to have to graph, now listen carefully, we're going to have to graph each inequality and then figure out where they agree on their shading. Got it? Where they agree on their shading. So let's graph this one first. Well, let's get the table of values first. Okay, so my x value for my vertex is negative b over 2a. That would be negative. My b is negative 6. My a is 1. So 2 times 1. So I end up with a negative sign here, a negative 6 up top, and a positive 2 in the bottom. So A, bring down my negative sign. A negative over a positive is negative. 6 over 2 is 3. A negative negative is positive. So the x value of my vertex is 3. Now let's substitute 3 into this top equation or inequality. So 3 squared, negative 6 times 3, positive 9. 3 squared is 9. Negative 6 times 3 is negative 18. Bring down your positive 9. You get 0. So the vertex is 3, comma, 0. Alright? Let's go ahead and put that right here. And so let's go up from 3, 4, 5. Let's go down from 3, 2, 1. Let's substitute 5 in to the first equation first, okay? Substitute 5 up here, so parentheses 5 squared, negative 6 times 5, positive 9. 5 squared is 25. Negative 6 times 5 is negative 30, positive 9. Alright, that's going to give us a positive 4 when you combine these numbers. So when you put in 5, you got out 4. Now, when I put 1 in, I should get out a 4. Let's see if I do, okay? 1 squared, negative 6 times 1, positive 9. 1 times 1 is 1. Negative 6 times 1 is negative 6, positive 9. Combine those and you get a 4. Check. We're good. Okay. Alright, next I'm going to substitute 4 in for x. 4 into my top equation. So, here we go. I have 4 squared, negative 6 times 4, positive 9. 4 times 4 is 16. Negative 6 times 4, negative 24, positive 9. Combine those and you get 1. So when I put 2 in, I should get a 1 out, okay? Let's see if I do. Put a 1 in, put a 2 in for x. 2 squared, negative 6 times 2, positive 9. 2 times 2 is 4. Negative 6 times 2 is negative 12, positive 9. You get out a 1, okay? So there we go. Check. So we're looking pretty good. Let's go ahead and plot these 5 ordered pairs. 5, 4 is the first one. 5, 4 is my first ordered pair, so we'll come over here. Over 5, up 4. My next ordered pair would be 4, 1. Over 4, up 1. My next ordered pair is 3, 0. Over 3, up and down 0. My next ordered pair is 2, 1. Over 2, up 1. And my next one's over 1 and up 4. Now, is it dotted or solid? Dotted. And thankfully, my favorite point to test, 0, 0, is obviously on the outside. So I have a dotted parabola, and I'm going to test 0, 0. Let's see what happens. I'm going to put a 0 in for y, 0 in for x, 0 squared is 0. Put a 0 in for x, negative 6 times 0 is 0, positive 9. 0, 0, positive 9 is 9. 0 is greater than 9. That is false. 0 is not greater than 9. So this ordered pair is false. So I'm not going to shade on the inside. I'm going to shade on the I'm not going to shade on the outside. I'm going to shade on the inside, but we don't want to shade. So we're going to draw arrows showing which way I would shade if I was going to. I'm going to shade later, okay? Alright, now let's move on to the other inequality. So here we go. First of all, let's find the x value of the negative sign. B would be 6. A is negative 1, so 2 times negative 1. That would give me a negative out front, a positive 6 up top, and a negative 2 in the bottom. A positive over a negative is negative. Bring down your negative sign. 6 over 2 is 3. Negative, negative is positive. So the x value of my vertex is 3. Now let's get out the y value of that vertex. So let's substitute 3 in for x. Negative, then parentheses, 3 squared, positive 6, then 3, negative 3. 3 times 3 is 9 with a negative sign. 6 times 3 is 18, and then negative 3. You should get out a 6, okay? A positive 6. So there's my vertex. So right in the middle, I'll put 3, 6. So going up, I have 4, 5. Going down, a 2, 1. Let's substitute 5 in first. So negative, then parentheses, then 5 squared. Positive 6, and then 5. And then negative 3. 5 times 5 is 25. Bring down your negative sign. 6 times 5 is positive 30. And then negative 3. Combine those and you'll get a 2. So when you substitute 5 in, you get out a 2. Now, let's substitute 1 in and we should get out a 2. Negative sign and then 1 squared. Positive 6, 1, and then negative 3. 1 times 1 is 1. Bring down your negative sign with it. Positive 6, negative 3. Combine those and you will get a 2. So it checks. Next we're going to substitute 4 into the inequality. And let's see what we get. Negative parentheses 4. Positive 6, 4, negative 3. 4 times 4 is 16. Bring down the negative sign. 6 times 4 is positive 24. And then negative 3. If you combine those, you will get a 5. So when we substitute 2 in, we should get out a 5, okay? Let's see if we do. Negative, then parentheses, then 2. Positive 6, then parentheses, then 2. Then negative 3. 2 times 2 is 4. Bring down the negative sign. 6 times 2 is 12. Negative 3. Combine those and you will get a 5. So it checks, okay? So here's my ordered pairs for this parabola. Notice it'll be dotted also. So here we go. 5, 2. Use a different color here. We'll use green. Over 5, up 2. 5, 2. 4, 5. Over 4, up 5. 3, 6. Over 3, up 6. Then the next ordered pair is over 2, up 5. And the next ordered pair is over 1, up 2. Okay, over 2, up 5, over 1, up 2. Now, I'm going to have a dotted green parabola. So there we go. And I'm really not sure if 0, 0 is going to be. It looks like it'll be on the outside, but I'm going to take no chances. I'm going to test this point here. That's definitely on the outside of this green parabola here. So this ordered pair is called 0, 5. 0, 5. So where the y is, I'll put a 5. And then put a 0 for x. That's x squared is 0. 6 times 0 is 0. Negative 3. So 5 is less than negative 3. That's false. 5 is greater than negative 3. So this ordered pair is false. Okay? So I'm not going to shade on the outside of the green. I'm going to shade on the inside of the green. So the green parabola says to shade on the inside. Do you see it okay? So think about it, guys. I got to stay inside the green parabola, but inside the red parabola. So the only area they agree in would be stay inside the green. And then when I hit right here, stay inside the red. Just like that. So that's my shaded area. You have to shade where the two parabolas agree. Now, relax. If you're having a hard time seeing where to shade, don't worry about it. Do this. Shade in red. See how the red parabola says shade on the inside? So shade on the inside of the red parabola. to shade over it lightly, okay? Now the green parabola says to shade on the inside, right? So shade inside the green parabola, just like you're supposed to. Do you see the intersection? Do you see where the red and green intersect? Right in this area here, that's where the red and green intersect. That's a way to do it, another way to do it. And I've taught you this before with linear inequality systems, is to shade the opposite. So green says shade on the inside, so I'm going to shade outside the green. I mean, everywhere outside the green. Really big. Covering as much space as I possibly can, okay? Alright, now, red says to shade on the inside, so I'm going to shade it outside the red as much as I can, as far out as I can, all the way around the red. Okay? And now if I've done that, what space is completely unshaded? This space right here. So that's your answer. That's another way to do it, okay? I hope that makes sense, guys. Trying to figure out where the two shadings agree can be a little confusing sometimes, but I hope that's been a help to you, and I do hope that makes sense, okay? If you have any questions, don't hesitate to call or email.